Okay, so yesterday I mentioned that I have custom chunking in the data ingest pipeline for my system, so I thought I would just go over that today. First, before anything else, there's a structural prerequisite that every source document requires UUID in its front matter. The ingest across the membrane is a hard failure if that's not present because the UUID is the provenance thread that runs from source document through every semantic chunk produced from it and then cascades downstream into everything else. So this isn't arbitrary document ingestion. I ensure the documents have a pre-existing shape knowing how the chunking model works, which is just aligned with markdown syntax, headings, tables, bullets, and everything. But my Obsidian vault is authored as such, and I have YAML AutoHawk keystrings set up so that any other documents I want, I'll just quickly use Python to transform. So the chunker walks documents line by line, maintaining a heading stack, and every heading pushes onto the stack and opens a new section. Same or higher level headings pop open a new section, and this way heading sections are structurally indexed to the intrinsic hierarchy of the document with full nesting state preserved. And then within each section, splits happen on blank lines and become a content unit. One paragraph, one content unit, one chunk. The full heading path and a line gap prepend the chunk content so that structural context is baked into what gets embedded. So this is full markdown parsing. Code fences are recognized and blocks are treated as atomic units rather than being bisected at internal blank lines. Hard character limits are also enforced, and when content exceeds the ceiling, the cut will happen at the nearest sentence end with a small overflow into the next chunk. Semantic units first, hard limit enforcement that respects sentence integrity second. Predetermined front matter fields that contribute to semantics are extracted as structured chunk indexed metadata, and that travels alongside every chunk. They are explicitly not embedded into the chunk text, but rather route into a parallel lexical index as filter and facet terms, completely separate from the semantic vector. So what standard rag chunking does is break up content on token windows, usually 256 to 512 tokens with a sliding overlap, which is typically around 10 to 20% of the window. So adjacent chunks share a decent seam of content across split points. That is a mechanical content agnostic process. No heading awareness, no block type awareness, no paragraph integrity. A heading just falls wherever it falls. A code block will get bisected if it's long enough. Two thematically unrelated paragraphs will fuse because they happen to sit within one window. The overlap is trying to do cleanup work that the chunking model itself creates the need for. The other common pattern is dumping metadata. Source labels, timestamps, front matter fields, they all dump directly into chunk text because it's simpler than building a separate channel. It works, but those terms become part of the semantic signal regardless of relevance to the actual content. Where this gets really interesting and impactful is downstream when it comes to embedding vectors. So prepending the heading path means every vector is topically anchored to where that chunk lives in the document hierarchy. Take, for example, a paragraph about authentication appearing under security in one document, and that same paragraph appearing again under user onboarding in another. Same surface text, different heading paths. So the vectors are going to diverge in the semantic direction of their respective headings. A query about access control surfaces the security instance, and a query about new user flows surfaces the onboarding one. In a sliding window system, those two paragraphs produce near identical vectors, and Retrieval has no structural signal to tell them apart. Because a hard limit enforcement keeps individual chunks bounded, paragraph level granularity keeps vectors tight, as opposed to normal rag systems where a 512 token window that spans multiple paragraphs will produce a vector that averages across topics. One bounded paragraph, one vector. This means less dilution and better cosine precision on focused queries. The metadata separation has a direct consequence too. If it went straight into the chunk text, every vector would bias towards any classification terms present in the metadata, regardless of the actual chunk content. Keeping the metadata out of the content means the vector captures only what the text says, not what the metadata classifies the document as. This also enables a two-axis retrieval strategy where semantic similarity and structured metadata matching operate independently without the two signals bleeding into each other. This way, hybrid retrieval is structural from the start instead of retrofitted later. Chunk IDs are stable hashes over the heading path, a section ordinal, and a paragraph ordinal, not over content. This diffs against prior manifest and only re-embeds chunks marked new or changed, so only content units that require updates cycle through the embedding step, and at corpus scale, that is a real efficiency property. But anyway, thanks for checking this out. Until next time.